I'm Daniel Turecek from Pure Storage, one of the tech leads there. And I will talk about the new features of Go 126, what it brought us. There's a lot of small and some bigger changes, I think with big impact. What I will talk about is there are some nice syntax sugar for pointers, self-referential generics, green tea garbage collector, 30% faster CGO calls, post-quantum security by default, and many small standard library improvements. I put these changes in section, so let's start with the changes to the language itself. So we have one small feature which will be very, I think, welcome by a lot of people, especially developers or projects that are working with JSON or protobufs, where there's a lot of pointers and where you need to assign like static values or expressions, especially like in testing. Up until now, it was not possible to assign a pointer to a value or expression, so we had to do various workarounds, like creating a temporary variable, like age 42, and take a pointer. Or I think a lot of the code bases are sort of full of these helper functions, either to specific type or maybe with generics that converts the value to a pointer. But now with the Go 126, the new function was improved and it can actually accept values or expressions. So this will make our lives much easier. We will be able to replace all these helper functions or temporary variables with just simple new. And defining JSONs or protobufs will be much easier. So that's one, I think, small, but like very impactful feature. The other change in the language itself is support for recursive type constraints in the generic templates for interfaces. Up until now, we were not able to put a reference in the definition of the interface to itself. So we had to use generic interface or any. But now it's possible. We can have the generic reference itself. Basically, to quote, when we have a generic interface with type T, the type T must implement an interface that is parameterized by T itself. What it's useful for is useful for when we want to really improve the enforcement of the types, or when we are developing a library for algebraic methods or functions like, I don't know, adding or calculating sums or different mathematical operations, or where we want to develop a very highly generic libraries. So now on the bottom, we can actually have an interface, let's say comparable here in this example, that specifies that it needs to receive a type that is also comparable by the type. I have a few examples to maybe clarify it, make it more clear. So one with the comparable. Let's imagine that we want to define a generic interface and then different object or structures that will implement this, that will implement the method compare, that will be comparing the type itself, let's say in this case int, to another type of the same, or another object of the same type, int. So we can now write a generic interface and then the implementation for int type that will compare one int to another. And then later we can use it in other functions, generic functions that will take this as an input. Before it was not possible, and it was developer could in principle put there a different type, maybe float instead of int, and it would still work. So now we can ensure the type safety, which will be very nice for like libraries. Another example is a cloner or cloning, when we also want to enforce the self type. Let's say we have a cloner interface that expect that we will clone the same object and we will return the same object. And here in the example, we have a user and we want to clone just the user and return the same object. So we can also define it this way and have a generic functions that will work with this cloner and will be do like duplications or depending on the use case. So this not only like makes the type safety better, but it also makes some of the APIs a bit easier. Let's say before we wanted to have the type safety and have a nice generic function that would calculate the maximum of 2 input let's say some numeric input values. So the workaround was, for example, that we added there another parameter, a comparable interface that would actually do the comparison. Now with Go 126, we can actually write it much simpler, just to input parameters and we return the output parameters. This is also useful for like Fluent API, basically the builder pattern, when we want to change several builder methods. And we want to also make sure that nobody like sort of injects like different type inside. So that in this example, we have some interface that defines a method with name, and we have two implementation, a bad builder and other builder. The bad builder actually implements a weird function that returns other builder, which is weird. But it before in Go 126, there will be a correct code, and we would be able to instantiate it as a Fluent other builder interface. I would assign a bad builder to it, and actually when we would use it, we would not receive the bad builder itself, but the completely different object. Now with Go 126, this will be a compiler error, so this will prevent us from doing these things. So that's the changes in the language. There are also some changes and improvements in the runtime itself of Go. So one thing I think you probably have heard, the green tea garbage collector was introduced in the last version of Go 125. Up until now, it was just experimental, but now it has matured and now it's on by default. So what does it bring? Before, the garbage collector was scanning individual objects like the pointers, so it was not very efficient, and sometimes it led to CPU stalls where basically the processor was waiting for memory. And so there was a like big room for improvement. Now with the green tea garbage collector, the mechanism changed a bit, that the pages are scanned in larger blocks up to 8 kilobytes, and it's a sequential scanning. Also, we use or we leverage the hardware support, so we use SMD SIMD instruction on the processor. So these are vector instructions that can scale for small objects, and we can get in one instruction up to 512 bits of memory in one go. And all these like smaller and other smaller improvements leads to a reduction in garbage collection times up to 10 to 40%, which is quite significant. So this is now not experimental, enabled by default, and makes things faster. There were also quite significant improvements in the speed of CGO. Like before, it was also not super optimized. So every time there was a call to like C part, there was a special processor state in Go that and there were a lot of like mechanism or atomic operations that would need to happen to switch between the like threads or calling to C part of the interface. Now this was optimized. Basically, this one extra syscall state that was used was completely removed, and now the system checks instead for the status of Go routines. So that brings another small optimization, and altogether it reduced the overhead of syscall up to 30%. So for usages when like using, I don't know, SQLite or libraries or other system libraries that were in C and we want to use them in Go, this will bring much better performance. The memory allocation was also improved. Before we had basically just one generic malloc function or function that was allocated. There was, because it was generic, it had to do a lot of checks. And so for really small objects, it was not that performant. Now what the Go team has done is for smaller objects up to like 512 bytes, they created specialized smaller routines or functions. So when we are allocating the memory, the Go now checks if it's a bigger object or smaller objects. And for smaller objects, it can skip certain checks and makes the allocation faster. So this reduced the allocation time by 30%. And as a security feature in this version of Go, we also has, or what was added is the randomization of the heap base address. So that prevents, some attacks when every time it would, before start a Go, it would be, the heap would be allocated starting at the same address. Now it's randomized, so it will be difficult for the attacker to actually get to the the right part of the memory. And the last feature in the runtime, I think will be also very useful. It's still experimental for now, but it's a detection of goroutine leaks or leaked goroutines. These are basically goroutines that are waiting for some synchronization primitive, like, I don't know, channel or some mutex. And when there's no, like, let's say, client that would change it. So it's basically waiting forever, and that consumes memory, and can, if we have a lot of these goroutines, it can lead to bad things. It was very difficult up until now to detect those, but in this version of Go, the special sorry special profiler goroutine leak was added, so it's possible by enabling it also with the Go experiment environment variable to detect these leaked goroutines. And the mechanism how it's done is basically using the garbage collector, and the garbage collector checks for the unreachable primitives, so basically for the channels that are not accessed anywhere, and this way it can detect some of the goroutines. It doesn't detect everything, but it will be very like huge step forward for detection of this like problem. So that was the runtime part. There were also some like bigger changes in the security part or security related things in Go. One quite nice feature for security is adding of the runtime secret package. What this package actually does, it's sort of a automatic paper shredder for the secrets on the stack and the heap. So it allows us to create ephemeral keys for whatever purpose, and make sure that when we are finished with them, the memory is erased completely, zero out. So if you have an attacker, they cannot access actually these temporary keys. For register stacks, it's basically immediate. For heap allocation, it's done this way that it's scheduled for the garbage collector as soon as possible, but there will be some small time between, so it's not immediate. It's an experimental feature, so again, it needs to be enabled by the Go experiment runtime secret. And what this package actually offers is a wrapper function, secrets tool, where inside this function, we can work with the keys, we can create them, and when we finish, the whole memory is cleaned up. Unfortunately, this is only available for Linux operating system at the moment, so only for AMD64, ARM64 architecture, so no Windows, sorry, or Mac. The other, I think, quite big addition to the secret handling in Go is the introduction of the hybrid public key encryptions. What does it bring? So it actually, this implements a standard RFC 9180, and it combines several steps that we needed to do manually before. So when we want to, for example, encode a large file, we couldn't just use these standard like public private keys because they are not designed for it for a large amount of data. So we needed to use before a combination, or we still need to use it, but it was a manual process. So first we needed to set up the we needed to share the encryption key, so use public private keys to create a shared secret between us and the receiver. And then with this shared key, actually encrypt the data with the symmetric encryption and send it over. This was several manual steps that could lead to potential problems where you missed something or you didn't configure something properly. So with this new package, this is done in one step where all these things is handled for you. So it makes it easier to use and also less error prone to introduce potential like mistakes or problems. It also adds the contextual security. So you can basically bind a context or a string or some identifier to the secret. The advantage is that if an attacker wanted to use this, they would not be able to reuse the secret. So it prevents from like sending the secret again over the wire. And I think the biggest addition here is that it also adds the support for post-quantum encryption. the hybrid key encapsulation mechanism. So basically it combines the current state of the art encryption with the encryption that should withstand the attacks with the quantum computers that will come later. So it adds the mechanism, the algorithms or processes, but it doesn't add the actual quantum algorithms yet because these are still like being defined. They are not finalized. But we have the infrastructure, and when they are ready, they can be just easily added with changing of the parameter, and we use the post-quantum encryption. And when you're using actually TLS encryption, TLS version 1.3, this is now added by default. So unless you override it, we will want to use these key encapsulation mechanism by default. These two keys, I will not read them. It will be very difficult to spell them. So just to give the example, what it looks like now to encode a message with encryption in just two, and decode it in two simple steps. You first define the key encapsulation method. So in this case, for example, the post-quantum one, you define the type of the symmetric key. And then you have some secret message or maybe content of the file. You can add this context key to make sure that nobody can send it again. You have a public key of the receiver, and with just one call, you encode the text, you send it to the receiver, and receiver having the private key and the parameters can decipher the text easily. So very simple. So that was the secrets. And now some changes in Go tooling commands and small changes in the standard library. This is also quite small change, but I think will be quite welcome. Is up until now we had only error s function that we can use as to check if the error was of a certain type. It had a few disadvantages. One, that we needed to have the variable either temporary or defined somewhere that we actually passed to this function. This function was not generic, so it accepted the interface. So there was a potential problem that you could put basically anything, nil or something completely different. So it could lead to problems. You were also not able to scope this to, like, let's say this if, so it leaked the name inside the function. So now Go added a new version or like extension of this function, which is called errors as type, which is generic, and one can pass actually just the type, doesn't need to have the variable. So this is more safe, and also it allows us to have everything scoped in the if. So like here in the example, we can use the standard error OK or value OK pattern as we use in other places. So again, it will improve the type safety. I don't know how many of you actually know this tool, GoFix. It was not used too much before, and so the Go team has decided to rewrite it completely and maybe a little bit repurpose it. The tool is now using the GoTFET engine, so basically the Go analysis framework. And what it does, it can actually modernize your Go. So intention is to use it every time there's a new features. You can run this tool, and it will upgrade your code and use the best practices or new ways of doing things. So for example, if before you were using interface, this tool will change it to any. If you were not using the new pattern, it will change it as well. It can even do things like you had the pointer to variable, and it will exchange it with the value itself. It will change things like the for loops. Before it was like sort of C++ style. Now it's the range, so it will also upgrade it. So there's like sort of the standard features, but it has also one extra nice feature, and that is to get rid of the helper functions over time, where you can, let's say you have an old helper function like this that before was maybe manual, some for loop. Later on, it was changed to use the slices contains, which was added, well, I don't know in which version of Go. And now what you can do, if you have it written like this, when you have the content of the function is the modern way, you can add this command go fix inline. And when you run this command, it will actually replace all the usages of this helper function with the content of the function itself. So basically, you get rid of this helper function completely automatically. And it actually even works with these helper functions for pointers with the values. It will actually fix everything correctly. So instead of helper function, you will have new and the value. So I think it will be quite useful to easily migrate your code. There's also a small change in the Go mode init when you set up a new repository. Before, it would always use the current version of your Golang that you had installed. So if you had, I don't know, 125, you would have Go mode set up with 125. Now with the new version of Go, it will always set up the Go project with one version before. So with version 126, it would do 125. In the future, when there's 127, you will set up the Go mode with 126. This is to make sure that when you create a new projects, there are like libraries that are like compatible with the current version of Go, because it always takes a bit of time to adopt the new version of Go. And then there was few like these two Go commands that probably are not that well known, like go cmd dots and go tool docs. So these were deleted and everything was unified on Go dots. So to get the documentation, you just use these commands for everything. And now just there are like a lot of small improvements in the standard library. I just picked few that might be interesting. The slog was extended, so it's not now possible to use multiple handlers. So maybe you want to output to a file, but also at the same time to standard output. So now you can use these slog new multi-handler and use that. So I think it's quite a nice feature. Another optimization is the in the bytes and buffer, a peak method. Now can return the bytes without actually advancing the buffer. So that's pretty cool. The FMT error F function was optimized. Before it required a bit of more allocation than the errors new function, and in some code base it was discouraged, when you were really thinking about performance, that if you didn't have a format string, you would use errors new. But now the recommendation really is to use error F, and the allocation is almost the same. So there's no like drawback if you use it, even if you have a just string without any formatting. And the testing HTTP client was extended. So now there was a bit problem when you were using certificates with the local server. You would need to rewrite the IP or the URL of the server, and the certificates would not be accepted. So what Go added is that you can use the example.com, and it will actually reconfigure inside to use your local server. So you can basically use domain and certificate, but it will use the like local host server. So for testing, it will be also quite nice. And the last thing is change to the pprof tool, where before we had this complicated graph by default, and the default now is the flame graph. So I think it will be much easier to see the performance than in this complicated graph. But you can still change to the original one if needed. And that's all the features. Any questions?